Kubernetes cluster. Reconciliation function tries to match the actual state of a Kubernetes cluster to the desired state defined in Git. A reconciliation loop is how often your Argo CD application will synchronize from the Git repository. In a DevOps or a GitOps world, software teams have multiple releases per day to production. The teams commit the application to the Git repository multiple times throughout the day. If multiple commits are done to the Git, how often does Argo CD synchronize the desired state from Git to the actual state in a Kubernetes environment? In a generic Argo CD configuration, the default timeout period is set to 3 minutes. This value is configurable and is used within the Argo CD repo server. As discussed earlier, the Argo CD repo server is responsible to retrieve the desired state from Git repo server, and it has a timeout option called as the application reconciliation timeout. If we check the environment variable of Argo CD repo server pod, it says that the key timeout reconciliation can be configured on a Argo CD config map. The Argo CD config map is created when we install Argo CD and is empty by default. We can patch this config map with timeout.reconciliation key and a custom value, for example, 300 seconds. After patching the config map, the Argo CD repo server deployment should be restarted for it to pick up the value from the config map. Once this is done, the Argo CD will check for changes in Git repository every 5 minutes. In the previous slide, we saw how the repo server depends on the reconciliation timeout parameter from Argo CD config map. With or without the timeout, the Argo CD repo server polls Git repositories every 3 to 5 minutes to see if any manifests have changed. The API server can be set up to receive webhook events in order to remove the polling delay. Within our Git provider, we can create the webhook by defining the Argo CD server instance endpoint appended with /API/webhook. In this example, I made use of GitHub, and once the webhook is created, for every push event to the Git repository, the webhook is going to send the events to the Argo CD server. And Argo CD repo server will in turn pull the committed changes. So by using a webhook, we can remove the polling delay, which we have seen in the earlier slide. Thank you. In this demo, we are going to configure a Git webhook on the repository so that whenever a change is pushed to the repository, it's going to send an event to the Argo CD server. So far, we created 2 applications. So let's go ahead and create another application and understand how the reconciliation works. So let me just create a new application named Git webhook because we will be configuring a webhook. I'll just use the default project with a manual synchronization policy. And let me auto-create the namespace. So for the repository, I'm going to use the GitOps Argo CD repository in which I have a Nginx application, right? So let me show you this Nginx app. So we have this Nginx app directory, which has a single deployment resource, which is going to deploy the Nginx app and has 1 replica. So let me just use that and let me add a destination. So let me just deploy this to a namespace called as webhook. Okay, so let me create this application. The application is created. Let me see and synchronize this. Okay, so if you see here, the application got synchronized, it deployed the application, and it created an Nginx pod. We don't have a service because we are just going to check the reconciliation option in Git in Argo CD. So now the application is synced. Okay, so let's try to make a change in one of the deployment manifest. So let's say instead of 1 replica, let me just scale this up to 2 replicas. Okay, and let me commit the change. So I made a change in the manifest. If I go to the Argo CD application, you can see that the sync status is synced and it is not out of sync. The reason why it is not out of sync is Argo CD has a default poll time as 3 minutes, where it is going to poll the repository every 3 minutes to check if there are any changes. So here it's going to wait till the poll period is activated, right? So if you don't want to wait, you can manually click on refresh, which is going to check the repository for any changes and gives you the out of sync option, right? So this is one way of checking for any changes within the repository, and it's kind of a hard way, right? You just need to manually click on refresh and check the synchronization status. Okay, so if you see now, it scaled to 2 pods. Okay, so what if we want to change this polling time from 3 minutes to 1 minute or 5 minutes or 10 minutes based on the project requirement? So we can change this polling time within the repo server. So I can go to the cluster. So let me check the Argo CD namespace, and let me just describe a pod. So this pod is going to be the Argo CD you know repo server. Okay, okay, repo server. Okay, so we will be getting a lot of data here, but we are not interested in all the data, so we'll only try to check the reconciliation parameter, right? So if you see here, the Argo CD repo server is the one which is responsible for connecting to the Git repository and fetching the data, basically. So it has an Argo CD reconciliation timeout environment parameter, which is going to take the timeout reconciliation data from the Argo CD config map. So if you want to set a timeout like 5 minutes or 10 minutes instead of the default 3 minutes, so you can go ahead and edit this Argo CD CM config map and add the timeout dot reconciliation parameter within the data field. So what we can basically do is we can go to Argo CD, get config map, Argo CD CM, right? So if you see here, by default, the Argo CD config map has no data field. It's an empty config map. So you can add data, and you can add timeout dot reconciliation and give some 300 seconds, right? So this is one way of setting up the timeout. And the other option is, if you want to get the synchronization status as soon as a push event was made to the repository, then we can make use of webhooks. So in this demo, we are going to see how the webhook works, right? So for configuring the webhook, so you can go to the Git repository. You can go to settings for that specific repository. You can check for webhooks. Within the webhooks, currently we don't have anything, right? So let's add a webhook. So this webhook is going to be, okay, let me check. Okay, we have Git, Gawk, Slack. I think we can go with the basic Git webhook. It's going to be a generic webhook. And what is the target URL? So the target URL is basically your Argo CD server URL appended by /API/webhook. And the method is post. The content type is application JSON. We don't have any secret for this. So let's trigger this webhook for push events. Okay. And I guess that should be enough. So let's add this webhook. Okay. So now the webhook has been added. Okay. So we can also test the delivery. So let's test a delivery. Okay, it's not working. So let me see why this is not working. Okay, let me retest this. Okay, so let's understand why we are getting this as, why this webhook is not being delivered. So if I click on the recent delivery and if I see the responses, so it's saying that the delivery cannot validate the certificate because we are using a self-send certificate and HTTPS. So GitAI is not able to verify the certificate, and hence it's not able to connect and send the webhook notification. So what we can do is, in order to overcome this, we can go ahead and add an insecure tag to the argo3 server. So I'll just quickly update the argo3 deployment. I'll edit the argo3 deployment of argo3 server. Okay, so let me just go here, and we should be seeing a lot of data over here. So I want to scroll down to the commands, right? So in the commands, it's going to start the argo3 server, and I want to start this in insecure mode. So I just need to add a tag called as insecure, and let me save this, right? So it should redeploy the pod, right? So a new pod is coming up. So let's, okay, the new pod is still running. So let's give it some time. In the meantime, let me check. So since I've used insecure, so this should no longer listen on HTTPS. It should listen on plain HTTP protocol. So let me log out of the UI once. If you see, it can't reach the site. So I guess I need to use HTTP instead of HTTPS. Yes, so now it is listening on HTTP, not HTTPS. So the same thing has to, okay, let me quickly log in. So now the application should be accessible on plain HTTP protocol. Okay, so let's make this change in the webhook as well. So in the webhook, instead of HTTPS, let's use HTTP, update the webhook, and then let's test the delivery. Right, if you see here, after making the server as insecure, so now we are able to send the notification. So now let's try to see how the synchronization happens, or how argo3 is going to poll the server whenever event is pushed in the Git repository. So let me go to GitOps argo3. So let me go to Nginx app, deployment YAML, and here, so currently it's deployed to 2 pods. Okay, so let me just open this in 2 separate tabs, right? Just to showcase how soon it is going to change the synchronization status from synced to out of sync. So now let me edit this file, and let's edit it to, let's say, 4 replicas. Okay, instead of 2, let's say 4. Okay, and let me just commit the changes. As soon as I do commit, the status should change. Right, if you see here, as soon as I committed it, the Git repository used the webhook and sent a notification to the argo3 server, and the Git repo checked for any changes, and since there was a change, the status changed to out of sync. Okay, so if I do synchronize, so it should deploy 4 pods, or it should deploy 2 more pods, so that the number of replicas match to 4. Okay, so let me do this one more time. So let me just scale down to 1 pod. Let me just quickly say 1 replica, commit. As soon as I commit it, the status changed to out of sync. Let me sync this one final time, and all the 3 pods get deleted, leaving 1 pod. So this is how we can make use of the reconciliation loop. So you can either set it as a timeout option using the argo3 config map, from where the repo server is going to read the timeout, and it's going to check for changes for that specific timeout period. Or we can also use a webhook within the Git repository, so that whenever we make a push event to the repository, it's going to automatically use the webhook and send the details to the argo3 server. And while using the webhook, so please make sure that you are using a valid TLS certificate if you're using Gittia, because Gittia cannot send webhook notifications on self-signed certificates, on you on URLs which are self-signed. Okay, so that's all for now. Thank you. Let's talk about argo3 application health checks. As seen earlier, argo3 continuously polls Git repositories for any new changes, and at the same time, argo3 will continuously check the status of Kubernetes resources. Let's assume argo3 has pulled a deployment manifest and applied it on a Kubernetes cluster. argo3 will monitor this deployment and designate it as unhealthy if it is unable to scale up to the necessary number of replicas. Similarly, there are various resource health checks which are already included in argo3. The first one is the healthy status, which is used when all the resources are 100% healthy. The progressing status is used if a resource is unhealthy but could still be healthy given time. The degraded status is used if the resource status indicates a failure or an inability to reach a healthy state in a timely manner. The missing status is used if resource is not present in the cluster. The suspended status is used if a resource is suspended or paused. So this is typically used, or it's a typical example is of a paused deployment. And finally, if a health assessment failed and actual health status is not known, an unknown status is used. So argo3 has many resource health checks available out of the box, but of course, it cannot cover all the resources available for Kubernetes. The following checks are made for specific types of Kubernetes resources. For Kubernetes secrets, it will determine whether the service is of type load balancer and verifies that the load balancer.ingress list isn't empty and that the host name or IP has at least one value. For ingress resources, similar to the service object, it will check if the status.loadbalancer.ingress is not empty and validate that there is at least one value for host name or IP. For persistent volume claims, it checks the PVC's status.phase field if checks the PVC is actually bounded to a persistent volume. For deployments, replica sets, stateful sets, and daemon sets, the observed generation must be equal to the desired generation and the updated number of replicas to be equal to the number of desired replicas. In some cases, we want or we might use policy rules for open policy agent, and these rules are stored in config maps. As of now, argo3 just checks if a config map exists and does not check any conditions. Not only a config map, if you cannot find a health check for your resources, you can also create a custom argo3 health check. argo3 supports custom health checks written in Lua scripting, which is a lightweight scripting language. Custom health checks can be defined in argo3 config map. So let's assume we have a scenario where we are deploying a front-end application which has a white background and displays three geometric shapes like a circle, rectangle, and a triangle. So colors of each shape is defined in a config map. So let's take this config map as an example. And if you see here, the triangle color is defined in white, or it's defined as white. So with no health checks in place, the config map gets created and the end users won't be able to see the triangle shape because it is in white color, which is the same as the background color. So we can configure a custom health check in argo3 config map, and it will be enforced for all the config maps. If the health check finds a config map with triangle color as white, it is going to set the status as degraded. Now, when the config map is created, the argo3 application status will be in degraded state with a custom message which was defined in the config map. Similarly, we can create custom health checks for any Kubernetes resources. For example, cron jobs, runtime class, roles, secrets, namespaces, pods, PVCs, and etc. You might be thinking, why trouble ourselves by creating a new custom health check? A health check makes troubleshooting simpler and provides quicker feedback. It is much easier to identify an Argo CD application that is in unhealthy state rather than going through all the associated config maps to find the error or the misconfiguration. Thank you. In this demo, we are going to create a custom health check for config maps. So within our GitOps Argo CD repository, we have a health check application. So we are going to deploy this application, and then we will be understanding why and how we can set up custom health checks for the config map. So here we have config map, deployment, and a service. So let's quickly create an application for the health check project. So let me quickly add a new application. Let me name this health check app. Let's deploy this to the default project with a manual sync policy and auto create namespace. The repository is GitOps Argo CD, and the path is health check. Okay. And if I scroll down, so let me just deploy this to the current cluster in the namespace health check. Okay. So let's quickly deploy this application, right? So this is currently in out of sync. So let's try to synchronize this. It's going to synchronize all the three resources, and I think the deployment has two replicas, so two pods are being created. So we can access this using the node port. So let me get the node port to access it. So the node port is 32731. Okay, it is. Okay, so this is a simple application or a simple PHP application which has random geometric shapes, and they just randomly move around in the canvas. And you can see we have four shapes which are visible, right? So we have a square, oval, circle, and a rectangle. Among with this, we also have the triangle, but currently the triangle is not visible because it is using the white color, right? So how are these colors assigned to these objects? So in the application, so we were making use of a config map, and all the colors for each shape were defined in the config map. And if you see here, all the colors are defined here. And for triangle, we were using the white color. And since the background is also white, so the triangle is not visible here. So here we can create a custom health check for config maps, which is going to change the Argo CD health to degraded if any of the object color is used as white. Okay, so what we can do here is we can go ahead and create a custom health check using Lua scripting. And the complete steps are documented within the Argo CD documentation. So basically speaking, we can create or define health checks within the Argo CD config map. So there we have to define a field called as resources dot customization dot health and the group. So this could be for any Kubernetes group, but we will be using config map in this case. And within this, you need to define an object which is kind of a global variable which contains the config map resource. And in this script at the end we have to give it an output status and an optional message, right? So let's try to configure this within our Argo CD config map. Let's go to the cluster. So within the cluster, so let me edit the config map Argo CD CM. So we don't have the data field here. So I guess I need to add the data field. And I've already copied the script for me with me. So I'll just paste the script and explain what is happening here. So the field name is resource.customization.health, and we are trying to create a custom health check for config map. So the kind is config map. And here I'm just using a variable HS, which is going to hold the initial status as healthy. And then it is going to check if the object, here the object is nothing but the config map data. It's written to an object field. It's a global variable. So within the object, it's going to check for data, and within the data, it's going to check for the triangle color. So I'm just using this script for checking the color of a specific object. So if the triangle color is equal to white, then the status is going to be changed to degraded. And I'm also setting up an optional message saying that use a different color for triangle. And I'm just going to return this HS object. Okay, so this is how I've defined the config map. So I can quickly save this. So before saving this, let me check the UI once. So currently, if you see, the application health is in healthy state because currently we don't have any custom health check, which is, checking the config maps triangle color. Okay, so let's save this config map. Okay, the config map is saved, and let me try to, synchronize this once again. Okay, or let me click on refresh. Right, so as soon as I click on refresh, now if you see here, the application status has changed to degraded. And you can also see that here within the UI, it is showing that the config map is degraded. So you can also click on config map, and let me check the events. Okay, I think I need to, okay, let's see. I think, let me check the details, right? So here within the config map details, it's saying that the health is degraded, and it also gives the health details, right? So we added a optional message. So the optional message will also be displayed here, right? So this is how, we can make use of custom health check so that it's easy for the operator to, identify any specific config map, which is, using some malformed, data. So what we can do is, so in order to make this application healthy again, and in order to see the triangle shape within the UI, so we can edit or make changes to the config map. So instead of white, so let me just use a red color for the triangle and commit this. So as soon as I commit it, so you can see that it changed to out of sync because this repository, we have added a Git webhook in the previous session. So it's going to just send the webhook notification. So let's try to synchronize this. And as soon as I synchronize this, if you see, the application health is healthy again, because now in the config map, the triangle color is red. It's no more white. Since it is not white, the custom health check passed. Okay. And if I try to refresh this page, I still won't be able to see the triangle because I need to redeploy the pod in order to, read the config map again. So let me just restart the deployment, which is going to, redeploy the pod for me. Right, so 2 new pods are created and the previous pods were deleted. So now let me refresh the UI, and if you see, now I'm able to see the triangle shape as well because I've changed it to red color. Okay, so this is just a basic example where I'm just using config map for changing the colors of the objects or the shapes. But you can use this in real-time examples as well, like if you're making use of the OPA rules engine. And OPA, it depends a lot on config maps. And if you're trying to manage those config maps, and if you want to quickly identify any issues with the config maps, we can create custom Lua scripts, embed them in the argo3 config map, and easily identify any issues within the config maps. Not only config maps, it applies to any resource which is there in Kubernetes. So that's all for now. Thank you. Let's have a look at the various Argo CD synchronization strategies. Argo CD allows customization to some aspects of how it synchronizes the desired state from Git to the target Kubernetes cluster. When Argo CD discovers a new version of your application in Git, it either performs a manual sync or an automated sync. If set to automatic, Argo CD will apply the changes, then update or create new resources in the target Kubernetes cluster. If it is set to manual, Argo CD will detect the changes, but it won't make any changes to the cluster until and unless a user manually clicks on the synchronize button within the UI or use the sync application CLI command. Argo CD's auto pruning feature describes what happens when files are deleted or removed from Git. Argo CD will also remove the corresponding resources from the cluster if it is enabled. And Argo CD won't delete anything from the cluster if this feature is disabled. Self-healing of cluster defines the Argo CD's ability to self-heal when kubectl edits are made directly to the cluster. Note that if you want to adhere to the GitHub standards, performing manual modifications in the cluster is not advised, and if enabled, the Argo CD will remove the changes and return the cluster to the desired state specified in Git. So let's take an example and understand all these options. So let's assume we have a Git repository which holds a couple of Kubernetes manifest files. And let's assume we have a Argo CD application, which is going to pull this manifest from the Git repository and create them within the Kubernetes cluster. So since we have a deployment YAML, it's going to create a deployment, replica set, and pod. And since we have a config map in the GitHub, it's also going to create a config map as well. So let's assume this Argo CD application is enabled to automatically synchronize the changes from the Git repository. And the other two options, which are self-healing and auto pruning, are currently disabled for this application. So when a user commits or adds a new service.yaml specification to GitHub, since the Argo CD application has automatic synchronization feature enabled, it is going to automatically pull the new service.yaml specification and create it within the Kubernetes cluster. And at the same time, if the user deletes or uses a git revert command to remove the service.yaml file, the service.yaml file will be removed from the Git repository, but no changes will be done on the Kubernetes cluster because as of now, the application is not enabled for auto pruning the resources. And if any user tries to make any manual changes directly on the cluster using the kubectl CLI command line, so for example, like deleting the config map, so the config map will be deleted and it won't be restored because the self-healing option is not yet enabled for this application. So this is the first option. So let's assume we have another application where both the automatic synchronization as well as the auto pruning option are enabled. So here again, it's going to deploy or create all the manifests which were part of the Git repository. So since we have deployment, config map, and service, all the three resources will be created automatically on the Kubernetes cluster. So now when the resources or when the user deletes the service.yaml from the Git repository, Argo CD, it's also going to remove the service from the Kubernetes cluster as well. So this happens automatically because as of now, this application has auto pruning enabled, right? So it is going to delete the files which are deleted from the Git repository. And here, if any user tries to make any manual modifications to the cluster through kubectl CLI, even those changes will be deleted and Argo CD won't replace them because the self-healing option is not yet enabled. In the third example, so let's assume we have the application which has auto sync enabled with self-healing option. So here the auto pruning option is disabled. So here If the user deletes the service.yaml specification from the Git repository, so it won't be deleted in the Kubernetes cluster. The reason why it won't be deleted here is in this Argo CD application, the auto pruning option is disabled. And at the same time, if any user tries to make any manual changes directly on the cluster, like deleting the config map, initially the config map will be deleted. But since the self-healing option is enabled on this Argo CD application, it is going to automatically pull the config map from the Git repository and create it on the Kubernetes cluster so that both the states match, right? So any manual changes to the Kubernetes cluster directly will result in self-healing of the cluster through the Argo CD application. And in the last example, let's assume the Argo CD application has all the three options enabled, such as the automatic synchronization, auto pruning of resources, and the self-healing of cluster. In this scenario, when the user removes any specific manifest from the Git repository, such as the service.yaml, since auto pruning is enabled on the Argo CD application, so the service will also be automatically deleted or removed from the Git repository. And at the same time, if any user tries to make any manual changes on the Kubernetes server using the kubectl CLI, such as deleting the config map will be deleted, but will be replaced by the config map which is there in the Git repository. So again, this happens automatically because the Argo CD application has the self-healing option enabled, right? So these are the three different sync strategies, and based upon your application requirement, you can either use one of them, both of them, or all three of them together. I hope you got a better understanding about sync strategies in this example. Thank you. In this demo, we are going to enable various synchronization strategies and see how they are going to work. So we will be making use of the same health check application which we just created in the last session. So here, currently, if you see the application details, and if I scroll down, the sync policy, so none are applied. As of now, we have not enabled automatic sync. We have not enabled auto pruning or auto healing, right? So let's see what happens if none are enabled, right? So one is obvious. If you don't enable automatic sync, so you need to manually sync every time when there is a change made in the Git repository. So let's assume we are updating the replicas within the deployment YAML. Okay, so if I update the number of replicas to 1 and save it, right? So you just see that the application is out of sync, but automatic sync will not occur because as of now it is disabled. So we need to manually click on the sync option so that the changes are made affected in the Kubernetes cluster as well, right? So now we only have one part. Similarly, if we try to, okay, let me just copy the entire deployment. Okay, and let's say we try to delete the deployment itself from the Git repository, right? So delete. So now we don't have the delete option. And here again, it's just going to say out of sync, and it won't automatically delete the deployment which is there in the Kubernetes cluster. So the deployment will still be there in the Kubernetes cluster. It won't be deleted, when you delete it within your Git repository. And third, so let me just go back and recreate. Actually, I need to do a simple git revert, but let me just recreate this. So okay, so I'm just going to recreate the deployment over here, right? Okay. Okay, so now it is synced because again I just created the same deployment again. And what about deleting the resources directly from the CLI? So far we have not directly modified the Kubernetes cluster using CLI, but it generally happens in real-time scenarios. So what I can do is, so I can go to the health check namespace, and I can delete the service. So what happens when I delete the service from the CLI directory? So if I do delete service random shapes service, it is going to delete it. And here again it's going to be out of sync. Okay, so basically speaking, the service is now deleted, so the users won't be able to access the UI. If I try to do a refresh on the UI, the users will not be able to access the UI because some developer has either accidentally or wantedly deleted the service from the Kubernetes cluster through a CLI or through the UI or some other means, right? So as far as GitOps is concerned, so these changes made using CLI should never be done, and it is not at all encouraged in the GitOps methodology. So let's try to enable. Okay, so let me just bring back the health of the application to the healthy condition, and then we will enable auto heal, auto pruning, and automatic synchronization as well. So now again the application is up to health. It has all the config map, services, and the deployments. And in deployments it has one replica. Okay, and the UI is also accessible because okay, the port number might have changed because I'm not using a static node port, so I can just use 30271. Yeah, if you're using a load balancer, it doesn't make sense because it's going to take care of the different ports. But since we are using node port, every time you recreate a service, you get a new node port. Okay, so let's try to enable synchronization policies on this application and see how they work. So I can enable autosync, right? So are you sure you want to enable automatic application synchronization? Yes. And along with it, I can also enable automatically pruning the resources. So once any resource is deleted in Git, it will also be deleted automatically in the Kubernetes cluster as well. So let's enable this. Okay, we want to enable resource pruning during automated application synchronization, and we also want to enable self heal as well, right? So let's see how each of this is going to work. Okay, so first, so let me just open this in a separate tab. I would like to show you how it works automatically. So first, let me scale the number of replicas, right? So let me just scale this to 4 replicas for the time being. Okay, so let me click on commit. As soon as I click on commit, if you see here, for a brief second, the synchronization status was out of sync. And since automatic sync is already enabled, it is going to automatically synchronize the changes. And if you see here, 4 pods are running. So as of now, the deployment was scaled up to 4 pods. So this happened automatically. You don't need to manually click on synchronize every time a change was made in the Git repository. So that is the first option. So what about the second one? So how does auto pruning works? So before auto pruning, so let's see how the self healing works. Okay, so let's try to delete the service. So earlier when we deleted the service, it was removed and the users were not able to access the UI. But now, since auto healing is enabled, the service will be automatically pulled from the Git repository and applied. So any changes done using the CLI will not come into effect, right? So let me quickly delete the service. So let me again do this as a small screen. I just want to show you how it works. Okay, this is the final thing. Okay. Okay, so let me just use delete service again. So this will be deleted. It will go for out of sync for a brief moment, and then it will again synchronize the service from Git repository. Right? If you see here, the service was never deleted. The reason is it is automatically syncing it again, right? So if I do this once again, right? If you see here, it just takes fraction of second for it to go out of sync and again fetch the service again, right? Right? If you see here, it happens quickly, right? So Since self-healing is enabled, it won't allow users to delete resources. It's going to automatically recreate them. So let me check the port number. Node port, it's listening on 30144. And again, the port number, will not come into issue in real time because we will be exposing the services using a load balancer or using ingress, right? So that's how self-healing works. And the final thing I want to show is about how auto-pruning works. So earlier, so if I go back to my Git repository, so earlier when where is this? Yeah, the deployment, right? So when I deleted this deployment, manifest from GitHub, it was still there in the Kubernetes, cluster. The reason was auto-pruning was not enabled earlier, but now we have enabled it. So let's see what happens. So let me delete the file. And it is also going to automatically delete the deployment resource from the Kubernetes cluster as well, because we have enabled auto pruning, right? So even if go check the UI, you won't get the UI anymore because we don't have the pods running. So you simply won't be able to see anything over here. It's still loading. Soon you will be seeing not found. And I can also show you the resources in the Kubernetes cluster as well. So if I do a quick kubectl get all in the health check, I only have a single service. We don't have any deployment, replica site, or any pods, right? Right. And again, the UI also, you can see that it's saying the site can't be reached, right? So this is how, the synchronization options work. You can either enable automatic sync, or you can enable all three of them, like self-healing, auto-pruning, and the automatic sync as well, right? So you can disable one or more as you wish. So that's how synchronization works. And that's all for now. Thank you.